Hi, brothers and sisters. I'm Osman Son Mohammed, your man, and today we're gonna learn mathematics. And I'll tell you to keep in touch if you want to understand the topic very well, because I'm gonna treat a topic that most students find it difficult to answer questions on that topic. And the topic is circle theorem. Okay, circle theorem um, is one of the topics that is very confusing when you set questions for students to answer. So I'm gonna make sure that every student who participates in this lesson understands everything. Before then, I'll tell you to subscribe to my channel if you have not, and then subscribe to my channel on your friends' phones, or tell your friends to subscribe to my channel. Share the videos to them and then like it. You can leave a comment. I'll go and read and reply if necessary. So right away, let's go to the board to learn our circle theorem. So right away, let's start with our plane geometry 2, which is talking about circles. Okay, so we start with naming of some of the parts of the circle. So you see, when we say a circle is just the set of points that are equidistant from a fixed point, which is the center. This is the center O, and then any distance from the center to any of the parts of the circle is equal. So a distance from here to here is equal, from here to here is equal. Let me see, from here to here, this distance is equal. You understand? So we call that distance radius. That is the equal distance that separates the fixed point from the set of points. Okay. So you see, this is um, a long. This is a long line passing through the center of the circle. So we call that one diameter, right? And you see, this diameter is 2 times the radius, because this is a radius, a radius, and then this is another radius. Okay, so let's move on. So this is here, we call this one radius still, if O is the center of the circle. Okay, AB, we can call AB a chord. Okay, chord. Take note of this word very well. This is a chord. Any line um passing through the circle and touches two parts of the circumference is called a chord, but it must be straight. You understand? Okay. So if they ask you to define the diameter, you can even say it's a special chord which passes through the center of the circle. You understand? So let's move on. When you draw two radii, this is a radii, this is another this is a radius, this is another radius. It makes an angle here, okay, and you can shade all this area. We call this area sector. Okay, this is a sector, this is another sector with this center O. Okay, so this from here to here is an arc. It makes an arc here. So let's name that one arc. Okay, so this is what's the name of this one? AB, line AB. You see, line AB is a chord. Okay, line AB is a chord. Center O, this is the center. Let's move on to our main topic, that is the circle theorems. Okay, we are going to learn two of the theorems. So right away, let's move to theorem 1. So this is the first theorem, and the first theorem says that the angle subtended by a chord at the center of a circle is twice the angle subtended by the same chord at the circumference. Okay, this is a chord, right? AB is a chord. Let's say O is the center. Okay, and then AB makes an angle at this place, and then the same AB is making an angle at this place, and let's say this angle is alpha. The theorem is saying that this theta is equal to 2 of this alpha. You understand? So you see, this is the same chord subtending an angle at the center and subtending an angle at the circumference. So the angle at the circumference is half the angle at the center, or the angle at the center is 2 times the angle at the circumference, because it's bigger. You understand? Okay, so they can bring this one in different forms. They can give you something like this. You see this one here, and then ask you to find maybe this angle, if they've given you 24 degrees here and x. So 240 degrees here and x. They can ask you to find x. Here you have to identify that there is a chord that is subtending an angle here and subtending another angle here. So you see the chord here is AB. You understand? You get it? So chord AB makes an angle here and makes an angle here. Then you will get your equation. The one at the center, which is 240 degrees, is equal to 2 times the one at the circumference. Understand? So here you divide both sides by 2 to get your angle 120 degrees. Okay, you can also bring something like this. You see the angle being subtended at the circumference is not passing through the center. You don't know. It's unlike this one where the center is between that, is inside that triangle. You understand? So some students get confused. You see, this is a chord subtending an angle at the center and subtending another angle at the circumference. It's just the same theorem. Understand? So here, if this is x and this is y, we see x, which is at the center and is bigger, is equal to 2 times the one at the circumference. Okay, so let's solve a question on that. Okay, here you say find the value of x and y if O is the center of the circle. You see, this angle is 95 degrees, this angle is 20 degrees, this is y and x. But we know that chord AB is subtending an angle at O and is subtending an angle at C too, you understand? And we know that the angle at O, that's the center, should be 2 times the angle at the circumference. So let's form our equation. X is equal to 2y. You understand? So this is an equation. And you see, ABC is a triangle. Look, ABC is a triangle. So the angles inside that triangle should sum up to 180. So let's add all the angles in ABC in that triangle. So it's 95 plus 20 plus y. And we say all the angles should sum up to 180 degrees. So this becomes what? 115 plus y is equal to 180. Then you make y the subject by sending this one to the other side of the equation. So y is equal to 180 minus 115. So y is equal to what? 65 degrees. Okay, let's go to the second theorem. Theorem number 2. That the angles subtended by the same chord at the same side of the chord are equal. You see, this is a chord, right? This is a chord. AB is a chord. It's subtending these angles x, y, and then z at the same side of what? Of the circle. And the theorem 2 is telling us that if this is what is happening, then x is equal to y and it's also equal to z. Understand? But you see, put in mind that when you have an angle here, when you have another angle being subtended over here, this let me say this is s. S is not equal to any of these ones. You understand? S is not equal to any of these ones. But the theorem is only telling us that x is equal to y is equal to z. But this s is at the other side of the chord, so it is not part. Okay. Let's go to other forms of expression for this theorem. So you see this is a circle, right? And then we have one chord here. We have another chord here. This is one invisible chord over here. Because once there are 2 points on the circle, you can draw a chord. You get it? 2 points on the circle and make a chord. Okay, so this is another chord. But here, you know that this is an angle, and which x is an angle. Which chord is subtending that angle? This chord called CD. Understand? Chord CD is making this x. Chord CD is forming this angle x. So we proceed to find another angle being subtended by the same chord. So this chord CD, if you can be observable, it is subtending B again. You understand? This B and then this one. So we say x is equal to B. So we say x is equal to B, okay? And then let's come to this A and Y. You see this A is being subtended by this angle, and that's this line, this chord AB. This chord AB is making that angle. And another angle being made by this same AB is Y. You understand? So we say A is equal to Y. So they can also give you something like this. You see, the problem is how to identify the invisible chords and then look at the angles they subtend. So when you have something like this, you know that this is a point, this is another point, and it can form a chord. You understand? This another point, this another point. It can form another chord. You get it? And so whenever they give you a circle, and then they identify 2 points on the circle, they know that those 2 points can make a line, an invisible chord. Okay, so See, this is a chord. This is another chord. You get it? So when you have a line here, and then you have another line here, they are all meeting here, okay? And the center of the circle is at this place. Know that this is an angle, right? This is an angle, and this angle is being subtended by this line, okay? After you found this line, then you proceed to find another angle being subtended by the same line or chord. So you see that this line is making an angle over here. That means these angles are equal. You can also take this chord, you understand? Maybe CD. This chord is making an angle over here. This angle is being made by the chord CD. Then you find another angle that this same CD is making. So if this is SA, then you say S is equal to A. So this one you will be given values to work on them all. They are not just going to put SA what. They are going to give you values. Then you form an equation. Okay. So let's move on to solve a question. So let's solve this particular question. That find the value of x and then y. This one you know that this is a chord, right? This is another chord. So let's name them A, B, C, and D. You see that this is a point. This is another point. It can form an invisible chord over here. You understand? This can also form an invisible chord over here. So first, when you have any question like this, you try to find the angles they are asking you to calculate. So here they said you should calculate for x. Then you find the chord that is subtending this angle. So CD is subtending this angle. You understand? This angle is being subtended by this line CD. Then you proceed to find another angle being subtended by this same chord. So this CD is subtending this 45 degrees. You understand? That means this x is equal to 45 degrees. You see, so the problem is just finding the invisible chord and knowing that it subtends a different angle. You understand? So let's come to y. They say you should find y. Then you locate this y. You find the chords that are subtending, or you find the lines that are subtending, that are making up this angle y. So this is angle y. You see, these lines meet at this point. You understand? So it means this chord AB is subtending this angle y, because you understand. So this chord AB is making this angle y. Then you find another angle that is being subtended by the same chord AB. So AB here, you see that AB is subtending another angle here, 29. So you see y is equal to 29 degrees. That's all.